Okay, folks, so we've learned a handful of shortcut derivative rules to use in lieu of using the long limit definition of the derivative. And so now we're going to look at two new rules, the product and quotient rule. The idea is that once we know the derivatives of smaller functions, we can find derivatives of their products, and we can find derivatives of their quotients. Let's go ahead and give this a shot. So this is a real quick recap of what we've learned so far. That the derivative of a constant, the derivative of the constant function is what? Well, it's just 0. Okay, I'll let you think about why that's so. Think about the expression something is constant, and then the derivative asks how does an expression change as the variable changes, and the derivative of constant 0. So I'll let you go ahead and compute f prime of x. There's not really a lot to compute here. Please do make sure that you're writing f prime of x equals and then stating what that answer is. In this case, I guess it's 0. I'll go ahead and do it for you. But actually write out f prime of x, or write out df dx, or something to that effect. Don't just write equals 0, or don't just write 0 on its own there. Okay, so the next one is the derivative of the identity function. And we saw in an earlier video that the derivative of the identity function is 1. Likewise, we saw in another video that the derivative of a power function is n x to the n minus 1. And it's interesting that actually holds for any rational number. We end up with that. Okay. So I'll let you find the derivative of y to the 7th. Make sure you do this one as well. I might have forgotten. Each one of these, make sure you do the example. Okay. And then in our most recent class, we showed that the derivative of the exponential function is itself. The derivative of the exponential function is just e to the x. So go ahead and compute the derivative of this function here. You'll notice there's not a whole lot to do in these problems, but pause the video and work through it as you need to. So now we get into our first rule that allows us to compute new derivatives based on knowing the derivatives of old functions. So the first one is the sum rule. And the phrase that we used is that the derivative of a sum is the sum of its derivatives. And what that says is we can take derivatives termwise. So if you're asked to find the derivative of a sum of two functions, you could really just compute the derivative of the two components. Okay. So I'll let you go ahead and do number 3 here, find the derivative of the sum of 3 functions. But of course, you just take the derivative of each of the terms. But again, make sure you're writing out k prime of x and stating what those are. So the last one that we've learned is the constant multiple rule, and it says that constants factor out of derivatives. And notice here I've done that for you. Here's the derivative of a constant times a function. So what can we do with that? Well, it's important to note that that constant's being multiplied to the function, and so constants factor out of that derivative expression. And so we can just go ahead and factor that constant out times the derivative of the original function. So that allows us to handle a question like this. Let's work this one together. We find that p prime of x is equal to 3 times 8 x to the 7th. Plus 4 e to the x. So in both these cases, the constant 3 and the constant 4 came along for the ride. I actually did several other derivative rules here. I had to distribute the derivative operator over the sum. So I took the derivative of this first expression plus the derivative of the second expression. Notice to take the derivative of this expression, I had to use the power rule. And to take the derivative of this one, I had to use the exponential rule. Okay. We can go ahead and clean this up. So we'll say that p prime of x is equal to 24 x to the 7th plus 4 e to the x. Okay. So notice that the last two derivatives are ways of building derivatives of new functions based on knowing the derivatives of old functions. Okay. What I'm saying here is that these two rules, the sum rule and the constant multiple rule, allow us to compute derivatives of new functions based on already knowing previous derivatives. So we now want to take the derivatives of products and quotients. Of functions, and we'll look at that in the next video.